Section 4.4, Laws of Logarithms, Part 1. There are 3 laws of logarithms. The first law says if I have a log, no matter the base, log base A, if what I'm taking the log of is being multiplied together, we can separate the two with addition. Log base A of A times B can be rewritten as log base A plus log base B. Whatever we're taking the log of, base A, if the operation here is division, then we separate with subtraction. Log base A of A raised to a power, what we can do is we can bring that power out front. If we bring that power out front, we end up with C log base A. Okay, so that would be using the laws from left to right. Multiplication, we separate with addition. Division, we separate with subtraction. Powers, we bring the powers out front. We can also use laws of logarithms, not only from left to right, but also from right to left. As long as these are the same base, if this is addition, I can bring A and B together with multiplication. As long as these are the same base and I have a subtraction, same base with subtraction, we can bring A and B together with division. If I have a constant out front of a logarithm, I can write that constant as an exponent. So our laws not only use the rules from left to right, but we can also use the laws from right to left, depending on what we want to do. Okay, so let's look at problem number 10. Use the law of logarithms to evaluate this expression. Okay, so let's look at base 6 and base 6. They're the same base, and we have addition between the two. Okay, so that means we're using law 1. Law 1 says as long as they're of the same base, base 6, as long as they're of the same base, base 6, we can bring these together with multiplication since we're using addition. So this becomes 9 times 24. Okay, if we take 9 times 24, 9 times 24 becomes 216. If we take 216 and I divide that by 6, I get 36. And we know dividing that by 6, we get 6. So this is the same as log base 6 of 6 cubed. And what did we learn in the last section? If this is log base 6, exponential base 6, log and exponentials are inverse functions. Those will cancel each other out, leaving us with a 3. Okay, so we have base 3, base 3. Okay, so looking at the same base, we try to look at the operation between the two. Base 3 with the operation of a minus tells us we can use rule 2. We can bring these two together. If subtraction is what's separating them, we can bring them together with division. We can bring them together with division. So that would be log base 3 of 135 divided by 45. Okay, so 135 divided by 45 in our calculator gives us a 3. So we have log base 3 of 3. Really, that's 3 to the first because a logarithm undoes an exponential. We're left with 1. Okay, use the law of logarithms to evaluate the expression. Okay, so let's look at our first example. For our first example, we have negative 1/3 log base 3. And all I'm going to do is I'm going to write 27 as 3 cubed. And why I did that is I know a log undoes an exponential. Since that log undoes the exponential, here we're just left with 3. Negative 1/3 times 3 is a negative 1, and we're done. Okay, log base 5 of 125 raised to the negative 1/2. The negative is bringing it up from the denominator. The square root is the same as the 1/2 power. Okay, so then looking at this problem, now we want to see if there's a way that we can write 125 in terms of base 5. Okay, so 125 divided by 5 is 25, and we know 25 is 5 times 5. So what we can do is we could just rewrite this as 5 cubed. Okay, log base 5, and I don't know why that equals there, sorry about that. So log base 5 of 5 to the 3rd to the negative 1/2. We didn't do anything, but we just rewrote 125 as 5 cubed. Then this becomes log base 5, powers raised to a power. We multiply those two together. That's an exponent rule. And we know a logarithm undoes an exponential, and so we're here left with a negative 3/2. Our goal is to get the log base and the exponential base the same so we can cancel one another out. Okay, this is the end of part 1.